At the beginning of every morning and the end of every evening, the sun creates a radiant show of colors in the sky. But how does the sun change the colors in the sky? The answer lies in the atmosphere scattering the light from the sun. The sun emits light from what is called the electromagnetic spectrum. The electromagnetic spectrum represents all types of radiation and energy that travels in waves. To find out how the sun changes the sky's colors, we will be focusing on the visible light segment of the electromagnetic spectrum. Visible light is what we can see with the human eye. If you were to shine visible light through a glass prism, the prism will bend the light and you would see the different wavelengths of all the colors that make up visible light. You might also see this happening when a rainbow forms. When the sunlight reaches the Earth, the nitrogen and oxygen molecules in our atmosphere will scatter the light in all directions. During the day, a process called Rayleigh scattering, which mostly scatters shorter wavelengths such as blue and violet around, explains why our sky is blue during the day. However, as the Earth turns and the sun gets lower in the sky, the sunlight now has a longer distance to travel to the Earth. When the sunlight finally reaches our eyes, most of the shorter wavelengths of light, which are the blue and violet light, have already scattered in the atmosphere. Since atmospheric molecules are roughly the same size of blue and violet's wavelength, those colors are scattered the most. After the blue and violet wavelengths have been scattered, what we see are the longer wavelengths, which are the red, orange, and yellow lights that make up the sunrises and sunsets. Now that we know how the sun changes the sky's colors, why is it important to study sunsets and sunrises? If there are large amounts of dust and pollution in the sky, the colors of the sunsets can actually be softened or less vibrant. And so over the past 40 years, NASA's Stratospheric Aerosol and Gas Experiment on the International Space Station has been collecting data to study and observe the atmosphere and the loss of Earth's ozone layer. Then in 2017, NASA launched SAGE 3 to measure gases and aerosols during sunsets and sunrises. The data gathered from SAGE and how the sunlight interacts with atmospheric particles can reveal its composition and how human activities affect its health. So, the next time you catch a sunset or sunrise, know that you're seeing more than just colors in the sky. You're seeing evidence that helps scientists understand our atmosphere and preserve our planet.